Good morning, everyone, and we all are welcome to this yet another series on the MBS Niger YouTube channel. And today we'll be talking about dysarthria, also known as motor speech disorder. We'll put it like this: motor speech disorders are divided into dysarthria and apraxia of speech. Okay, so uh, we'll be talking about both of them. So instead of saying today we are talking about dysarthria, we'll say today we are talking about motor speech disorders, which are collectively dysarthria and apraxia of speech. All right, so let's move on. We'll say motor speech disorders, which are the dysarthria and the apraxia of speech, result from neurological impairments in the areas of brains responsible for motor planning, motor programming, and neuromuscular control and execution of speech. And they account for 41% of acquired communication disorders. Okay, guys, what they are trying to tell us here is that the areas of the brain which are responsible for production of speech, when these areas of the brain are affected, that's when we have issues of dysarthria and apraxia of speech coming up. Okay, so still talking about motor speech disorders, we say speech production deficit that results from the impairments of the neuromuscular and or motor control system. This may co-occur with other language impairments. Other oral movements besides speech may be impaired, including chewing and swallowing. This is like, let me say, maybe let me say muscles of the tongue are affected. Of course, you know that swallowing, chewing, and swallowing may be impaired too, as well as your speech too. Prevalence and incidence among adults with acquired communication disorders. 41% have motor speech disorders, right? 36% are dysarthria and 5% are apraxia of speech. We'll get to see all this dysarthria and apraxia of speech that we are talking about. So, defining characteristics of prevalent types of motor speech disorders, right? So, motor planning stroke programming disorders, inability to group and sequence the relevant muscles with respect to each other. Apraxia of speech is acquired and developmental, right? So motor execution orders. This is deficit in the physiological and movement abilities of the muscles. This is when we have dysarthria coming through. So I hope with this we have known the difference between dysarthria and apraxia of speech, right? Apraxia of speech has to do with like your inability to group. I think that's like physiological. Why dysarthria has to do with the physical muscles, right? These muscles are affected physically. So let's get into the definition of this dysarthria that we are talking about specifically. We'll say that dysarthria can cause a reduction in speaking rates, right? Abnormal prosodic features and significant intelligibility deficit, resulting in a reduced ability to communicate successfully. Hope I've seen the definition of dysarthria. All right. Still talking about dysarthria, I would say dysarthria is a speech diagnostic term that can be used to classify various types of neuromuscular speech disturbances. Dysarthria results from notable degrees of one or more abnormalities involving speech musculature, right? Including weakness, paralysis, incoordination, sensory deprivation, exaggerated reflex patterns, uncontrollable movement activities, and excess or reduced tone. Still talking about dysarthria, I'll say the name of each dysarthria subtype is partially derived from the basic characteristics of the overlying movement disturbances. Normally, normal speech production involves the integration and coordination of five primary physiological subsystems. That's the respiration, that's your breathing supporting, that's your phonation, that's your voice production. You have articulation, that's the pronunciation of words. We have resonation, we have the nasal, that's the nasal versus oral voice quality, and the prosody rate. The prosody, that's the reading inflection patterns of speech. These collectively are the mechanism that make it possible for speech production to occur. So we'll get to talk about all these four subsystems of speech production, right? We'll get to see the respiration phonatory. We get to see the resonatory. You get to see the articulatory. All right, so the muscles and muscle groups in these subsystems must be coordinated in time and space, right? Talking about respiratory system now, we'll say the speech production requires airflow. That's when we have the pulmonary airstream mechanism. This mechanism pushes air out of the lung through trachea, that's the windpipe, to produce airflow. We have the ingressive inhalation and exhalation. They are into ratio 1:6. That's inhalation and exhalation ratio during speech production. Exhalation cycle needs to be extended in time for completion of utterances and modulation to reflect stress. Talking about the phonatory system, this includes various muscles and structures in the larynx and regulates the production of voice and the intonational aspect of speech. Right? Vocal folds are brought closely together and the air flows build up to set the vocal folds into vibration. The vocal folds are stretched lengthwise to manipulate the frequency or pitch of the voice. Alright, so now let's talk about the resonatory system. This regulates the vibration of the airflow as it moves from the pharynx into the oral nasal cavity. It also manipulates the shape and size of the vocal tract for maintaining normal sound quality. Okay, it also manipulates the velopharyngeal port, whether nasal cavity is used as a vibrating chamber for determining the nasality of sounds. Right, let's go talk about the articulatory system. Control of the articulators within the oral cavity to manipulate the outgoing airflow. Major structures that the articulatory system are the lower jaw, are the lips, and the tongue, right? The tongue is the most important. Right. You could see that's just like the continuation of what we're talking about. So now let's talk about motor control. To maintain speed and fluency, the sequences of movements are programmed together as a single movement unit. All right. That's where you have degree of freedom coming in. Degree of freedom is the number of elements that can be independently controlled. The greater the degree of freedom, the greater the challenge to speak, right? Planning, programming, and execution. Motor planning, that's the processes that define the sequence articulatory goal. This prior to the initiation of movement. And motor programming is a process that establish and prepare the flow of motor info across the muscles, as well as control timing and force of movement prior to initiation of movement, right? Motor execution. These are processes that activate relevant muscles during and after initiation of movement. What are the symptoms of dysarthria? Having spoken about the mechanism that help to bring dysarthria into occurrences, what are the symptoms of dysarthria? How will you know a patient is down with dysarthria? We get to say that virtually all individuals with spastic dysarthria present with a broad spectrum of speech disturbances, including abnormal excessive nasal speech quality, imprecise articulation such as slurred sound production and period of speech unintelligibility, slow labored rate of speech, strained or strangled voice quality, limited vocal pitch and loudness range and control, uncoordinated, shallow, forced, uncontrolled, and overall disruptive speech. All these are also the symptoms of dysarthria. Problems with emotional breakdown. You have swallowing difficulty. So, what about classification of motor speech disorders? Acquired. And this is like damage to a previously intact nervous system caused by cerebrovascular accident, right? Developmental. These diseases can be acquired due to all this accident, traumatic brain injury. And talking about developmental, this is abnormal development of nervous system, right? This can be caused by disease and so on. So talking about acquired dysarthria, this is where you get the explanation of all what we spoke about. Disruption, speech sounds slow and all that. You could just pause this video to take a look at these points, all right? And types of acquired, you have the spastic, flaccid, atasic. I don't think you really need all this, right? But just going through this briefly. It's a spastic dysarthria. It's a type of motor speech disorder affecting speech articulation caused by lesions of the cortical bulbar tract, right? Think we're saying through. It should just be a summary, and where you want to like read, you could like just pause this video and get to jot down some point. Atasic dysarthria. Atasic dysarthria is caused by damage to the cerebellum or its connection to the cerebral cortex or brainstem. Okay. We'll pause this video, get to check out the point. That's the main reason why I use handouts to make my videos, okay? Because minus me speaking to you, you could just basically come to this YouTube channel to learn, to read, okay? You hearing my voice and you're reading with your eyes. Trust me, you won't forget it. So talking about hypokinetic dysarthria, is caused by damage to the upper brainstem region. Okay, guys. With this, if you haven't subscribed to our YouTube channel, kindly do subscribe to our YouTube channel, the MBBS Niger. Subscribe, like our video, share our video, and comment on our videos too. Talking about hyperkinetic dysarthria, hyperkinetic dysarthria is generally caused by damage to the nerve pathways and centers within the depths of the brain, known as the basal ganglia. Pause this video and get to pick out some point. From here. Talking about flaccid dysarthria. Flaccid dysarthria is caused by damage to the nerves that emerge from the brainstem. This is talking about dysarthria, different types of dysarthria. Now you could see a patient down with Dysarthria. You could see his tongue. His tongue is greatly affected. It's not really smooth like ours, okay? Still talking about flaccid Dysarthria. Now here I think they're talking about mixed Dysarthria. It's caused by simultaneous damage to two or more primary motor components of the nervous system. Unilateral upper motor neuron Dysarthria. Unilateral upper motor neuron Dysarthria is caused by damage to either left or right upper motor neuron tract anywhere along its course to the brainstem, spinal cord. Moderate weakness and paralysis of lower face. Tongue, arm, leg on the side of the body opposite to the damaged upper motor neuron tract. Right. Finally, we're talking about developmental Dysarthria. Developmental Dysarthria present at birth and usually occurs along with non-disturbances to the neuromotor functioning. It can be caused by pre, peri, or postnatal damages to the nervous system. Most common types are the spastic and the dyskinetic. Okay, guys, with this, I think we have acquired a PhD in Dysarthria. If Dysarthria was a course, I know you might have acquired a PhD in Dysarthria because we went through almost everything that is related to Dysarthria. So with this, I would like to tell us a goodbye for now and see you guys in the next tutorial. Do subscribe to my YouTube channel, like my video, comment on my video, and share our videos too. See you guys in the next.